Okay, my clock shows that it's the top of the hour, so we will get started. One of the chairs at least will be watching the chat, and so please put yourself on the queue if you, but you just use the Meet Echo tool to put yourself on the queue. You don't need to use the chat, but we will try to watch if for some reason you have trouble with the queue. I will now go through the chair's presentation, and then we will begin the regular meeting materials. Reminder to go with the note. Well, our ADs, I believe all of the ADs have asked all the chairs to issue this reminder of BCP 54 that folks need to be respectful and courteous. We discussed the technical material and solutions for the global internet across a range of requirements, and that everybody's here to participate. We don't get into personal insults or anything else. We have actually, this time around, been pretty good about all of this. We're doing okay, but we wanted to remind folks anyway, so thank you. Here is the agenda. It is not an especially crowded agenda. We have 2 hours and we're scheduled for 85 minutes. I wouldn't be surprised if some conversations take longer, but we're going to go through it. So, for example, the TWAMP draft will be up after I finish going through the chair's presentation, and then we'll go through the rest of these. I don't see any reason in walking you through this. This has been on the meeting material, the agenda page, and we will go through each of these presentations. So, but I wanted to make sure folks could see it. If anybody sees a need to adjust the agenda, please put yourself on the queue now so we can recognize you. Not seeing anything, thank you. Meeting minutes are in CodeMD. Actually, are they, or are they in notes? Well, they're in the link that you get to if you click the note-taking tool on the top of this. I think they changed the name for this. Right. One of the other ADs said it's actually notes.ietf.org, followed rather than codeimd.ietf.org. I didn't edit this properly. It's my fault. Sorry, folks. Thank you, Eric. But the link at the top will take you there. Please do help our secretary take minutes there. And so queue management, enter the queue using the tool. Mute yourself when you are not speaking. When you're on the queue, I or whichever chair is running things will tell you when it's your turn. Unmute yourself, speak. Go ahead. If you are speaking, you're welcome to share video of yourself as well. Otherwise, please do not. And it is not necessary to share video. As you can tell, I'm not doing so. I don't actually have a video camera on this laptop. The session is being recorded, as the little button on the bottom of the screen tells you, and those recordings are subject to the IETF rules as we shared them earlier. So before we go into the other material, what else have we done? Wanted to start with the adoption call on the compression draft. I managed that adoption call completion because my co-chairs were recused. That's why I'm presenting this material. The full details are at the link that is included here. The adoption call has completed. Please don't get word picky about what's on this slide. If you want to pick on words, it's the words in the message I sent. I've tried to summarize so people will know what the context is. So my conclusions were that there was rough consensus to adopt the document. Very rough, but rough consensus. The document, when it is posted, will include a specified open issue section. Separately, I am in the process of establishing an issue tracker because I do not expect the editors to be updating the draft for every individual issue and every individual change to every individual issue. The open issue section is for major issues, as the text I provided says. We will use a GitHub-based issue tracker because that's what the tools people tell me is the thing we are supposed to use for issue tracking now. We will not be putting the draft into GitHub unless for some reason the editors decide they want to. I won't prohibit it, I'm just not expecting it. And all discussion of issues will be on the mailing list. The issue tracker is just so we don't lose track of any. There was enough discussion, and heck, I had trouble making sure I saw all the issues. So we will use an issue tracker to make sure nothing gets lost. But there will be a delay in posting the spring working group version of this draft until 6man has in front of them, not adopted, not yet last called, although that's in the open issues, but in front of them, a draft which deals with the relationship of CSIDs and RFC 4291. That draft may deal with more topics than that. That's up to 6man and the folks who write the draft. The constraint from where I sit, because of the policy the spring chairs announced more than 6 months ago, is that we have to have such a draft to say that's the one we're looking at, to say that that the question is being dealt with. Not there is a discrepancy, but the question of whether there is one and how much of one and what the right response to a potential discrepancy is being dealt with. And so that is that is the delay. My expectation is that draft will be the one that the 6man leadership is in the process of appointing authors for. And there is a presentation from them in the 6man session about that draft. If they don't post something that addresses this, then we'll deal with it another way. We'll figure that out when we come to it. I'm not trying to write a adoption call conclusion that deals with every imaginable contingency. That's why we cope. Are there any questions about this? I do not see anybody leaping into the queue. I do not see anybody typing into the chat. I will assume people understand it sufficiently, and thank you. Since IETF 111, we do have some new documents. The compressed SID list requirements document, the compressed SID list analysis document, both were adopted as working group documents and published. They're both there. And the Spring SR redundancy document is now a working group document. So that we're slowly moving things forward. On the first two, those now belong to the working group. The working group can work on them, improve them, modify them. Whether we will publish them as RFCs is a separate question, which will be decided later. We have two working group last calls going on, as far as I can tell. One is the one on the LSH document. I'm not going to talk much about that since I'm a co-author on it, but the last call is going on. And one is on the MPLS path segments. There are final editorial nits in progress, and the Shepherd write-up is in progress. The Shepherd, Jim, just sent an email saying, guys, have all the open issue comments that were made been addressed? Because that's the requirement. Everything has to get addressed, not necessarily agreed to, but addressed. We don't ignore comments. So that's where we stand on that one. It should be, the last call should be done soon. We have submitted to the ISG Spring Segment Routing Policy. RAD Martin is handling that. To answer Srihari's point, no, the question at this stage, there are different issues. There are multiple different issues. At this stage, the question for Spring is not whether 6man has blessed the relationship, but rather whether they have a document that addresses the relationship. What will happen later is up to 6-man, but there is a coupling as noted in the open issues in the adoption call. When we get to last call, we have to know what the relationship is, and what happens exactly depends on exactly what 6-man says about the relationship. But I'm not going to prejudge that. As Eric pointed out in the chat, 6-man has picked a lead author. I don't know whether they're going to have more authors or whether Suresh Krishnan is going to write it by himself. He's quite capable of doing so. Very experienced guy. But that's up to 6-man. Thank you, Eric, for reminding me that I had seen that 6-man had picked a lead editor for that. We have nothing new on the RFC editor website. And with that, we are done with the chair's presentation. I'll give folks one more chance to ask questions or get on the queue. Failing that, I will stop sharing. Rakesh, you need to put yourself in the queue, click the start. You're doing so. Please click the start sharing button. And you need to request that you need to unmute yourself as well.
Hi, Joel. Hi, everyone. Good morning. Good afternoon. You
Thank
hear
you.
me?
Yes.
So, Joel, I shared or you share it. Sorry, was
You
it?
should be able to share it yourself, so you can just drive.
Okay.
There's it should be the button right next to the one you used to join the queue. Should be share preloaded slides. Should let you share.
Yeah, I made a request to
I
share.
need to grant it. Yeah, there it
Yeah.
is. Last time I drove, but it's much better if you guys can. It says the screen share is being, there it is. We're good. Go ahead.
All right. Thanks, Joel. Hi, everyone. My name is Rakesh Gandhi, and I'm presenting the enhanced SRPM draft on behalf of my co-authors listed here. So the agenda is we'll look at the requirements and the scope of the draft, the history and summary, and the next steps. So the basic requirement is to for the performance measurement in SR networks for end-to-end SR paths. It's applicable to both SR MPLS and SRv6 data planes. So the goal and for this particular draft is no session reflector dependency for one-way delay measurement. So session reflector is not aware of the measurement protocol or some of the machineries. It's the state is in the packet, the spirit of SR, and we're trying to achieve a higher session scale and faster detection interval. So the scope is using the RFC 8762, the simple TWAM stamp protocol, and the extensions defined in the recently adopted SRPM draft in Spring. So this draft builds on top of the SRPM draft. So the history of the draft is this draft was initially published a year and a half ago. It has gone through multiple revisions, and they were presented in MPLS and Spring working group sessions. So there were very good feedbacks received from the working group, and the latest draft, we believe, addresses them. So in the Spring SRPM stamp draft, there is look back mode defined for SR policy, where the packets are transmitted for each segment list of the SR policy. And what's new here is the session reflector forwards them just like data traffic without punting them to control plane and processing them. So it's kind of it's agnostic to the protocol machinery, and this is what allows to achieve the higher scale and faster intervals for any violations. So in the existing working group document, we can measure the round trip delay only. So in the enhanced mode, that's using the network programming function, um, it optimizes the operations, but at the same time, timestamp is added in the packet. So at a particular location, using network programming function for SRMPLS and SRv6, uh, it adds the received timestamps and forwards the packet just like data packet. So this allows us to measure one-way delay for the end-to-end path. It extends the SRPM provisioning model by defining a new measurement mode. We call it enhanced loopback mode, as well as the network programming function, which includes the timestamp label for MPLS or the SRv6 endpoint behavior. That will come with its offset in the stamp, which is a 16 and 32-bit in different modes of the packet format. And that's basically it.
Rakesh, I may stop you for a moment. Somebody misunderstood something, or something you said didn't add up right. Can I let Greg ask you a question about what you've said just a minute ago for clarification?
Sure, yeah.
Greg, please go ahead. Try to specify the context since we flipped a few slides.
Yes, thank you, Rakesh. So you're saying that this method enables one-way measurement. At the
That's
same
right.
time, you are saying that the reflector doesn't have a state, and the packet does not leave the data plane.
Right.
So how you can do that if the format of the reflected packet is different from the format of the received packet from the sender. So they are very different, and you cannot really just take a packet and swap their destination and source address. More so, um, if you don't have a state in the reflector, what you are measuring, you're not measuring one way, you are measuring round trip. And because you are traversing one way or downstream their segment tunnel, and the upstream, I don't know, I can assume it's IP network. So they're divided by two, the round trip time might be not characteristic, not accurate. So I think that there is some serious problem with this.
Thanks, Greg. So the loopback measurement mode is defined in the working group document, and it explains how it works for the SR policy with proper header and whatnot. You had some good comments, and the draft was updated to address those comments. So if you can have a look at this working group document, please, and let us know
Mhm.
if you have additional comments. But that is for the round trip delay, and this is an optimization where the session reflector using the network programming function adds the receive timestamp and forwards the packet. So the packet processing is also explained in the enhanced loopback mode draft on how it works. So if you could have a look at that and let us know your comments, would be
Mhm.
appreciated.
Yeah, I had, and I sent a comment before the meeting. So again, I see that there is a contradiction between the statements because their segment routing programming has nothing to do or does not introduce any special mode in the stamp. So to do processing of stem packets in a real one-way measurement, reflector has to be stateful. So encapsulation of the underlay of the network is really not relevant.
Yeah, so draft
I'm
explains it, and there is a
again,
summary.
Rakesh, I apologize. I just will leave with this. Okay, so we can continue on the mailing list. Thank you.
Yeah, thanks. I haven't seen your latest mail if you just sent it, but I will reply to it. So stamp test packets are shown here, and the idea is that the sender sends the transmit timestamp T1 in the session sender packet, and the reflector adds the receive timestamp T2 at offset 16 in an authenticated mode and offset 32 in the authenticated mode. So these are well-defined locations in the stamp packets. This is motivation for using stamp as well. And there is for SR MPLS timestamp MPLS label is defined. This is network programming function which will cause the reflector node to do the adding of the timestamp and forward the packet. There are two ways of achieving this. Reverse path can be IP, where MPLS header will be removed and the source destination address in the IP header of the packet will make sure the packet comes back to the sender. Or reverse path can be SR MPLS, where the entire label stack is carried in the packet. So this is an example of a reflector receives a packet with timestamp label TBA1. It will cause the reflector to add timestamp label 2, timestamp 2, and forward the packet back to the sender. In case of SRv6, there are two new end functions defined for two different offsets. Idea is very similar, where timestamp 2 will be added by the reflector, and the reverse path can be IP or SRv6. And the similar way, entire the seed list is carried if reverse path is SRv6 in SRH. The notifications are the thresholds are provisioned. So what we are measuring one-way delay. So a threshold is configured and notification is generated when the threshold is crossed. Same way for the synthetic packet loss. Session state is this is mentioned in the existing working group document, where the state up or down is declared based on if packet is being received or not. So welcome your comments and suggestions. Many thanks for the great discussions on the SRPM draft during the working group adoption, and looking forward to your comments on this draft as well. And we are requesting a Spring working group adoption for this draft as well. And many thanks. Any comments, questions?
For the requesting, please send an email and Shraddha will add it to the list, but people are getting on the queue right now. Stuart, you're first.
Sorry, I'm curious as to how you avoid the ECMP issue with this, that ECMP will give you a different answer when you run this. Is this ECMP safe? Is it for MPLS?
Yeah, so I mean, for ECMP, there are standard techniques of, for example, using the entropy label. So if you
so you're requiring the entropy label to be in there for an ECMP safe measurement. That's absolutely fine, but you must say that it must be there.
Okay.
Because you don't show it there in the stack I was just looking at.
Yes, yeah, we can add that test here.
No, it has to be. It has to be, high level required, because people will get the wrong answer, and we can't publish a document where people get the wrong answer.
Yeah, definitely. Good comment, Stuart. We'll add it.
Okay, Andrew, you're up.
Oh, thanks. Just a quick question. I noticed that in the case of the IP side, you're setting the session sender sets the destination address equal to the session sender address, etc. Effectively, they're going out reversed, relying on the labels, if I'm reading this correctly, to get to the other path. Now, my question on this would be, what is the impact on stuff like BCP38 on a network that is running multiple ASNs, etc., that is actually protecting against, incorrect source, incorrect destination, etc., on incoming, particularly considering, we use a lot of TWAMP, etc., for various probes, and that reversal of addresses does kind of worry me. So I'd just like to hear your thoughts on, the potential impacts on things like BCP38 and anti-spoofing protection here.
Yeah, thanks, Andrew, for the question. So yeah, if that is not suitable for the network, so the second method, which is reverse path, can be SRMPLS, so the node seed or the entire label stack can be used to bring the packet back to the sender. So both methods are defined, and depending on the deployment or what is being used in the network, one of them can be selected. Again, this has been around. Many RFCs use the swapping of the source addresses already, and it's also no different here.
To explore it more, take it to the list. Thank you. Okay, thank you, Rakesh. I don't see any more people in the queue. There are some issues which you're going to have to deal with on the list, but that's fine. So you need to push the stop sharing button so that Yongxing can start sharing for the next presentation. Okay, we just wait for the tool to catch up there. Your slides are now shared. Go ahead, Yongxing.
Hello, can you hear me?
Go ahead.
Thank you. Hello, everyone. I'm Yongqing Zhu from China Telecom. Today, my presentation is segment routing for end-to-end IETF network slicing. As we know, network slicing can be used to meet the connectivity and the performance requirements of different services or customers in a shared network. And IETF networks can be realized by mapping one or group of overlay VPNs to a VTN as the underlay. Furthermore, an end-to-end IETF network slice may span multiple network domains. In each domain, IETF network slice traffic needs to be mapped to a local VTN. Here, in this document, we describe the SR extensions to support end-to-end IETF network slice. Let's have a look at the IETF network slice framework and realization. There are three parts for this framework. The first one is concepts and the general framework, which is described in the draft IETF network slices. The second one is realization framework based on VPN, TE, and other technologies, which is described in draft IETF enhanced VPN. And the last one is framework of end-to-end IETF network slice. Add to the realization, there are some drafts. The first one is the ARSA-based network slice realization. We can achieve it by making use of SR resource-aware segments. The second one is the scalable network slice realization. We can achieve it by making use of data plane within resource ID. And the third one is the end-to-end IETF network slice, which introduce global VTN ID and mapping mechanisms. Here, our proposed draft, the Spring SR E2E IETF network slicing. It listed here. In this draft, we introduced the VTN binding segments. The VTN binding segments, that is to say, the B-seed, is a special B-seed used by the domain and nodes to steer traffic into a local VTN. The VTN B-seed can be instantiated with SRv6 or SRMPR data plane. There are 4 functions for the VTN B-seed. The first one is the end.b6 in caps, which maps the packet to a list of resource-aware segments, which are associated with a local VTN. This function, as for the SRv6, it equals to the SRv6 end.b6.incaps function. The second function is end.vtn incaps. This function determines the local VTN ID based on local mapping information and instructs the encapsulation of the local VTN ID to the data packet. The second one is end.bvtn.incaps. This function obtains the local VTN ID from the packet and instructs the encapsulation of the local VTN ID to the data packet. The last one is the end.b6vtn.incaps. This function identifies an SR policy which is bound to a local VTN. As for SRv6, all the above functions use in the SRv6. We have talked about it on the last slides. There are some pseudo code for these functions. For example, the end.vtn.incaps for the S14. We use this the update of IPv6 DA with a segment list, and next set the VTN ID option to V in the hop by hop extension header. And the other functions such as and bvtn and incaps and the .b6 v10.encaps function as a v6 function is listed here. The v10 b6 in alpha and plus is similarly is similar. v10 b6 can be instantiated using alpha and plus binding seeds with different semantics. You can refer to the draft for the details. Next, we will refine this draft and welcome the comments and the feedback. Thank you.
Any questions? Does anybody wish to get in the queue? Vishnu, go ahead.
This is Pawan Biram. Juniper, can you go to slide 3, if you can? The one where you showed all the relevant draft documents that. Okay. Yeah. If there is difficulty in going to slide 3, I'll just go ahead and state my question. So we do have a working group adopted framework document in T's, like you pointed out, for what we call IETF network slices. So though the original interest from the working group participants was largely with respect to how the IETF network slice can cater to what the industry refers to as transport slicing, there hasn't really been any conscious attempt either by the authors or the working group to limit the scope of that construct. So I don't quite get the idea of having a separate end-to-end slicing framework document. So if all that this document is talking about is about how you can go ahead and stitch multiple VTNs together, I would limit the scope of this document to that and talk in terms of stitching VTNs together instead of putting this under the aegis of something like a end-to-end slicing term. That's my comment.
Yongxing, do you want to respond before we go to the next person? Okay, Xi, go ahead.
Hi, I just want to help to reply to Pavan's comments on the end-to-end slice framework draft. Actually, that one will be presented tomorrow in the TIS session, and this document is mainly about the segment routing-based extension to solve this multi-domain mapping and concatenation issue we want to solve. Okay. We can discuss further about the end-to-end slicing framework in the TIS meeting.
Okay, Adrian.
Thank you, Joel. Speaking as the editor of the TIS network slicing framework, which is intended to be sort of all embracing for IETF network slices, I want to caution the authors here to be very careful about the term end-to-end, because the concept of an end-to-end network slice has already been used by 3GPP to mean something much broader, of which an IETF technology network slice would form only part. So I think take a little bit of care, especially as well that the concept of end has a strange meaning in IETF. So maybe step back from that headline title of end-to-end IETF network slice and talk more about what it is you're achieving rather than getting hooked on that terminology.
Thank you, Adrian. Yongxing, if you will stop sharing, we will now move on to the next presenter. Saleh, I believe you're next, and I'm sorry if I'm mispronouncing names. Yeah, there. So you should click the share button, and then I will give you permission to do so. There you go. And now as soon as they actually appear, there you are. Thank you. Go ahead.
Hello everyone, I am Salih from Juniper Networks. Today I am presenting SRv6 interdomain mapping sheets on behalf of my co-authors. So this draft introduces three new SRv6 endpoint behaviors, namely end.replace, end.replace b6, and end.db6. These sheets helps in building SRv6 path spanning multiple SRv6 domain. So we will get SRv6 service continuity over multiple SRv6 transport domains. Each domain can have its own TE mechanisms. Among the three slides, the end.replace and end.replace b6 sheets helps in transport interworking. So this sheets also helps when there are multiple intent-based paths present in the network. In such scenarios also, this mechanism can help in getting easy stitching. That means it can work with the procedures mentioned under BGP classical transport or similar mechanisms for getting multiple end-to-end intent-based paths across the network. So the last is end.db6, it helps in service interworking. So now we will look at the two use cases. The first use case is for the transport interworking. So this use case is from the seamless SR draft. So basically, the figure shows three different ASs: AS1, AS2, and AS3. The ASPR1 to ASPR8 are border nodes between the ASs. A given ASPR runs eBGP session with the ASPRs in the adjacent ASs. The ASPR also runs IBGP sessions with the other ASPRs in the same AS. RRs can also be used to achieve the full mesh of IBGP requirement. Instead of IBGP or eBGP, this can also be replaced with the intent-based BGP CT or similar mechanisms. So these sheets actually helps in replacing the destination address in the incoming packet. One thing to notice, there is no segment list change with respect to these two sheets. The next slide. Yeah, so the processing of end.replace. So this actually replaces the destination address with a new sheet and forward the packet on an outgoing interface. So this idea is similar to the swap operation on an MPLS data plane. There is no segment list change, segment left change, and it cannot be the last seed in the SRH. The procedure is mentioned in the draft. When SRH is processed, after doing the initial checks, decrement IPv6 hop limit by 1, update IPv6 destination address with the new destination address mapped with the end.replace it, to submit the packet to the IPv6 module for transmission to the new destination via the member of J, where it belongs to one or more of the adjacencies of BGP. So one thumb rule is for a route, if the BGP next stop is one hop away, then while advertising we use end.replace it. A detailed procedure probably we will update in the next version of the draft with an example. So the next seed is end.replace b6. So this is where apart from replacing the destination address with a new seed, it will also add an additional SRv6 header. So this is similar to swap and push in the MPLS data plane. Here also there is no segment left change, and it cannot be the last seed in the SRH. For a route, if the next stop is multi-hop away, then while advertising we pick end.replace b6 seed. As mentioned, in the draft, when an SRH is processed after the initial checks, decrement IPv6 hop limit by 1, update the IPv6 destination address with the new destination address mapped with end.replace b6. push an IPv6 header with SRH, set outer IPv6 source address equal to the source address, the address of the border node, set the outer payload length, traffic class, hop limit, and flow label fields, set the outer next hop header value, submit the packet to IPv6 module for transmission to the first SID. Yeah, so the second use case is for the service interworking. So here there are two SRv6 domain, AS1 and AS2. The services are running between PE1 and PE2 in option B style. So the ABRs can also be RRs. So there are no VRF configs at the ABRs or RRs. The self next hop is configured at the RRs. The requirement here is to avoid service route lookup on ABR1 and ABR2 to provide an option B style end-to-end connectivity. At RR, we decapsulate the received SRv6 header and encapsulate a new SRv6 header with source address same as the RR. So, like mentioned, like the SID decapsulate the received SRv6 header and encapsulate a new SRv6 header. When an SRH, the procedure is mentioned in the draft, like when an SRH is received after the checks, remove the outer IPv6 header with all its extension headers, push the new IPv6 header with the SRv6 SIDs associated with the end.db6 SID in an SRH. Set outer IPv6 SA equal to the T and IPv6 destination address to the first SID in the segment list. Set of outer payload length, traffic class, hop limit, and flow label fields. Set then outer next header value. Submit the packet to the IPv6 module for the transmission to the first SID. Yeah, so so we request the working group to review the document and provide comments and feedback.
Okay, thank you, Salah. There are some questions in the queue. Zhenbin.
Hello?
Yes,
Hi,
go ahead.
Okay. This is Zhenbin from Huawei. So my understanding, the enter replace is similar as the mapping the swap function of MPRS, but because I'm not sure my understanding is right or not, because in the SRv6, I don't think we need not the swap, because this is the segment list can be encapsulated as this the ingress node. So there's not necessary to swap the segment in the midpoint. So why we introduce this the end replace function for the seed?
Yeah, okay. So basically, there are different mechanisms for multiple domain when there are multiple domains involved. Like the ingress itself is computing the full path, or a PC is involved. So this mechanism is where the BGP is involved for stitching the end-to-end path. These domains are heterogeneous, and there is actually on the borders there is the protocol reachability is not leaked or not learned by the ingress PE1. It is actually stitched automatically by BGP. So this is for option C connectivity across multiple domains. So this is another way to address the same thing.
Okay.
Ketan, you're next.
Thanks for your draft and for the presentation. My question was on the end dot.
Somebody has a lot of background noise. Make sure you are muted if you're not speaking. Thank you. Go ahead, Ketan.
My question was on the n.db6, Salih, on the pseudocode for that. So this is was a service kind of mapping, right? So binding. My question is whether this the service SID, is that like a per prefix, or is it a per verb allocation in this case?
Yeah, so this is per prefix, Per prefix, at least, yeah. So the mechanism is mainly the service prefix advertisement. This is option B. So the RRs can also will have service for every prefix. This will be looked up.
Okay. So the suggestion just to maybe clarify that in the draft, and I would say perhaps consider upper verb as well.
Sure, Ketan. Thanks.
Thank you.
Okay, Cheng Li. Cheng, go ahead.
Okay, can you hear me? Okay.
Yes.
The first one is that, yeah, I don't really understand why we need to like replace the destination address. Like you said, is used for achieving the option C, and I could like to see the text is explicitly in the draft. And the second question is that when the seed list contains only one single seed in binding seed n dot b6 as defined in the RFC 8986, what's the difference between the like end b6 and the end replace 6? I can see the action is the same.
Yeah. To the first one, option C, how the procedure works with an example. Probably we will update in the subsequent version of the draft. The second one, as I mentioned, it is based on when you start advertising. We look at the BGP next hop from where this BGP protocol next hop reachability is learned. So if it is only one hop away, we advertise the replace. If it is not, if there are multiple seeds to reach the other domain, then yeah, we will do an additional encapsulation B6. But yeah, depending on the network and where this is getting stitched to, one of them will be picked based on the situation or that characteristics of that particular border node. Yeah, probably we will update with an example so that will be more clear in the draft.
Yeah, I think we need more clarification of this draft. And I am really curious about why we need this like option C or something like this in the draft. Yeah, thank you.
Okay, Zhenbin, you're back up. And I'm going to close the queue after Xiaofu because we're getting a little long on time.
Okay.
Go ahead, Zhenbin.
Okay. Thanks, Joy. Zhenmin again. Sorry, I quick. I'm still feel strange about this the purpose of this type of seed, because you know the SRv6, the major advantage of SRv6 can still use the IPv6 forwarding to traverse the different domains. But for MPRs, it has to keep the huge number of the forwarding entries for the mapping between the labels. So that's for the IP for the SRv6, we can use the IPv6, and the IPv6 can also use the aggregate to reduce the forwarding entries. So I mean, so this is the advantage of SRv6. But if we introduce this mapping seed in the SRv6 like the SMPRs, I think this is just reduce the advantage of SRv6. That's my concern.
Yeah, let me answer it. Yeah, so as I mentioned, like there are different scenarios. Like as you mentioned, if if a network is properly numbered and everybody has a similar mechanism and everything kind of a fresh deployment, then you can even leak SRv6 locators across domains and you can get the protocol next up reachability. But this is a scenario where there are multiple heterogeneous SRv6 domains and they have planned to work together. So there is already option C, the seamless SR draft talk about that particular use case. And also there could be multiple SRv6 intent paths like the BGP CT or BGP car. So there also automatic stitching has to happen at the border. So it is for a different use case, but I think it's all these different mechanisms are really required for different kind of deployment.
Okay, thank you, Sala. Darren, go ahead.
Yeah, first, thanks for the work to publish this, and I know it's a revision 0. So I don't expect you to answer this now, but maybe in a future revision of the draft. It would be interesting to see how an SR source selects one of these behaviors when it builds its path versus another behavior. Just to see the cases where these SIDS behaviors are used or not used, or one of them is used instead of another. That'd be an interesting illustration to see.
Yeah, definitely. We will update that in the next version of the draft.
Great, thank you.
Okay, Xiaofu.
The replace can you hear
Go
me?
ahead. Yes, we can.
Okay. I think the replace seems enough. Why need the replace?
You seem to have some audio problems, though. It was hard to understand you, and your audio seems to have dropped. May I
Okay, let
suggest you
me
put it in?
repeat. My question is very simple. I think the replace seems enough. Why need the replace B6?
Yeah, so as I mentioned, if you see the diagram, right? So there are IBGP sessions inside AS. So in order to cross one AS, you need multiple seats in that particular AS to be in the SRH. So that's why you need to push an additional SRH at the corresponding ingress border nodes. So I think this will be clear probably with an example when we mention it in the draft.
Okay, Sal, thank you all. Darren, Xiaofu, please take yourselves off the queue. Sala, please stop sharing. And Giuseppe, I believe you're up now.
Yeah, can you hear me?
Can hear you. You need to go use the button at the top to share preloaded slides to share your slides. I will now give you permission.
Yeah.
And I will let you know as soon as they're visible, and then you may begin. I don't know what causes this delay. There you go. Go ahead.
Okay. Yeah, hello everybody. This is an update about the SRH encapsulation for alternate marking method. Okay. Just a quick recap about what is the alternate marking methodology. I guess most of you are familiar with this methodology. This is an OM passive performance measurement that allow loss delay and delay variation metrics, and it is defined in two RFC in IPPM, RFC 8321 and 8889. Regarding the application to IPv6 data plane, there is already a document in ISG evaluation from 6 months. This document defines two new alternate marking options header, both op by op and destination option. Of course, this destination option can be applicable to SRv6, to SRH, since destination option before the routing header are processed by each node in the route list. So that is an identity in the SR path. This document defines how the alternate marking is carried as SRH TLV. SRH TLV, of course, is defined in the RFC 8754. Then we explain why we want to use the SRH TLV in the next slide. Yeah, this is just the format of the SRH TLV is the same as we already defined for IPv6, so there is no difference between this TLV and the TLV that we encoded in as op by op or destination option. So there are two bits that are the marking bits. There is the flow monitor identification that is required to reduce the per node configuration, to simplify the counters handling, and also to facilitate the correlation, the data export, and so on. This identification can be assigned by a central controller or can be pseudo-randomly generated by the source node. Regarding the usage of this TLV, also in this case, the application is the same as we have for IPv6. So the ingress node, as a part of the SRH encapsulation, may add the TLV if it supports the alternate marking functionality. Regarding the intermediate SR node or egress node, if they are capable to process the alternate marking TLV, they can simply read the TLV. They don't need to write, so only check if the TLV is present and read the values of the bits. Otherwise, if the intermediate or egress node are not capable of processing this TLV, this is not a big problem, because if nodes are not capable of processing this TLV, of course the measurement can be done only for the supporting nodes. So this is one of the, let's say, the advantages of the alternate marking, because you don't have, so the intermediate node and ending node do not have to write the option, the TLV. Yeah, in this slide, we are going to explain better the motivation why we need to define the SRH TLV in addition to the destination option. As I said, the approach with destination option and SRH is already feasible to allow performance measurement for SRv6, for SRH. But the issue is that if we are going to use destination option plus SRH, this requires the usage of 2 extension headers. And as you may know, there is some discussion on the operational implication of adding too many extension headers for IPv6. So in the case of SRH, in the case of SRv6, we are investigating this new proposal to use the same option that we already defined for IPv6 to be encoded into the SRH TLV. Of course, this document would update the alternate marking application only in the case of SRv6, only in the case of SRH. Indeed, in case of SRH, alternate marking could be applied through this TLV, the SRH TLV, but for all the other cases with the IPv6 data plane, the use of op by op and destination option is, of course, the only choice to carry alternate marking information. And in the end, there is no other difference, so because the TLV is exactly the same. Another point that we can consider, that considering that we have a compression design, an SRH compression design team that is working on the optimization solution for SRv6 seed compression and SRH implementation, this also could also benefit the use of SRH TLV, but it's just an hypothesis. So maybe the last slide is about the next step. So of course, this is a straightforward way to apply alternate marking to SRv6. The companion, we can say the companion document, as I said, is an ISG evaluation. And we are open to comments, discussion about this proposal. I hope I have clarified the background and the motivation for this work. Thank you.
Ron, go ahead.
I understand that sometimes you want alt-mark functionality in every node along the delivery path. And in that case, you use the HPH. Sometimes you want it only at the ultimate destination, and then you use the destination option. And sometimes you want it only at segment endpoints. Well, when you want it at segment endpoints, you have two choices. One is to encode it in an SRH TLV. The other is just to use the same destination option in a destination options header that precedes the routing header. Why did you choose the TLV in the SRH as opposed to the destination option that precedes the routing header?
Yeah, as also I did also mention this before. So you are right. So destination option plus SRH will have the same effect of SRH TLV. So the issue is that this solution is only applicable in the case of SRH in order to avoid the use of two extension headers that may have some operational issues sometimes for a PV6. So it is, let's say, a dedicated solution for SRH. And we can say that if accepted, this document would suggest or would recommend that for SRH, the only option is to use the SRH TLV and not the destination option plus SRH. So we are going to define a single solution, but not two.
Why would you not want to make it more general and make it work for any other routing header?
Because it's just to leverage this capability of SRH to be extended through TLV. And I understand your point, but the solution for all the routing header is already in the 6-month draft, right? Because here we are defining the destination option header that of course can be applicable to all the routing header. So this is only for the SRH. Since with SRH we have this the possibility to use this kind of TLV, this kind of extension, we aim to leverage and in our mind it can be an optimized solution only for SRH, of course.
It seems like you already have a solution in the destination option, and you can put a destination option before the routing header. So it seems like you're coming up with a second solution to a problem you've already solved.
Okay, I believe, Giuseppe, you've answered. We need to, that topic should be taken to the list as to whether we want to do this or not. Greg has dropped off because I think he was asking the same question. So thank you, Giuseppe. You can stop sharing. Sammy, you're up. There, it's in the process of displaying your slides. I'll let you know when they're visible, and then you can start. You can probably tell yourself when they're visible, but I figure it's nice to know that somebody else is seeing it. It isn't yet visible.
Sure, yeah. Can you hear me, I guess?
Yes, we can hear you.
Okay.
Thank you for checking that. I'm still waiting for it to show the slides. It said it was sharing, but then I don't see them.
Yeah, I don't see them either.
Why don't you stop and restart and let's see what happens.
Okay.
I'll give you permission again. A new deck is being shared.
Okay,
that's better. Now at least it's looking the same way I've seen everybody else look, so I assume it will appear in a moment. There you are.
Okay.
Go ahead.
Okay. Thank you. Yeah. So I guess I can. Oh, I can move the slides this way. Okay. I was wondering how they move the slides. Okay. Yeah. Good morning, everyone. My name is Sami Boutros, and I'm going to be presenting on behalf of the authors here of the draft. How can we use segment routing concepts applied to the service control plane. This draft is focusing initially on ELAN service. It's Ethernet, an Ethernet service in a LAN environment. So what does it mean to apply the segment routing concept to services here? It's not new that segment routing define an sRGB for service as well. This could have global significance across the networks. We are saying the sRGB concept for services can be used here, which means that every service globally in a given domain will have a unique index, right, in that domain. So it will point to a unique label within this sRGB. So, for example, if in a given domain we are numbering the services for ELAN here, then a service numbered 65 could have a service index 65 on all the provider routers or provider edge routers providing that service. So I think the key here is that we are talking about, segment routing came with, of course, a few concepts here, and the goal was simplicity, meaning, they brought in the concept of simplifying the network. This is what segment routing is about. So, and they did a great job in the underlay by eliminating protocols like LDP, for example, in the underlay, the sRGB concept, globalizing the label space across the network. So all those concepts have been applied to the underlay and simplified the underlay control plane greatly. And the question here, can we use that as well to simplify the control plane for the service? And we are talking about ELAN, for example, here. So going to the next slide. So here we are just comparing or going back to history here and looking at pseudo-war that was a building block for ELAN services when applied to to a service provider network. So it was the building block that we built over the IP MPLS network. And historically, the pseudo-war context, was presenting two pieces of information. Was presenting what service we are talking about and what endpoint to. Those two pieces are important, especially if you are going to be doing data plane learning over a pseudo-war. The node that hosts the pseudo-war here need to know from where the packets are coming, so the endpoint is important, and as well need to know what service is in question here to be able to do the proper data plane McLearning. But this combining those two pieces of information in one context led to a scale issue. So, for example, if you have 10,000 services configured on 100 node, then each node would need to maintain 1 million pseudo-war context or 1 million service ID for those for all the endpoints in all 10,000 service. As well, pseudo-war really didn't support legacy layer 2 network any active-active redundancy. So what we are proposing here, as a way to improve the scale for that old technology or previous technology, is to split the two pieces of information into two contexts. One presenting the service, and here we are talking more about data plane, one presenting the service and one presenting the endpoint. So if you imagine, and we'll go more in details in the next slides, that we split those two pieces of information to two SIDs in a SID list, where one will present from where the packet is coming, present the endpoint, and one presents the service, then your scale will look quite different, right? You would have only 10,000 SIDs to present the services, and the endpoint, given that's encoded underneath the service in a header, then you won't have the same scale problems that you have with pseudo-war. As well, if we leverage more of the segment routing concepts here, especially the Anycast SID, we can introduce the active-active redundancy to that layer 2 world or that service itself. So this is an illustration on how we can achieve that as well in control plane. So so we're talking about how are we going to be in a given domain inside the service provider network, learn dynamically about what services are configured where, right? So what we are proposing here is that if each node would advertise to all other nodes the services configured with as a bit mask of all the SID offsets, let's say, that it is configured with, then we can really decrease significantly the amount of signaling in the network compared to any previous technology. Because if you imagine the 10,000 service we talked about in the example, and we are trying to advertise those services across the network, and each service is presented by a bit in a signaling message, you could have only one message, one control plane message, by which one node can teach all nodes in the network about what services it's configured with. That's, of course, a significant decrease in terms of number of control plane messages that can be exchanged. So we're talking about, instead of 1 million pseudo-R signaling done by a given node, it's only one message that's being sent. So one message compared to 1 million, right? So of course, upon receiving that message that's being sent by one node to all other nodes, like as shown here, node 5, for example, is sending what services configured with to all other nodes, then all other nodes can as well figure out, the membership of nodes in a given service. So typically in layer 2 network, you need to know what are the members that that correspond to the service for function like flooding, for example, because layer 2 is all, especially with data plane McLearning, is all about flood and learn. So when you flood, you need to know who are the members of a given layer 2 service to be able to flood unknown unicast or broadcast layer 2 packet to it. So now you can learn the membership by simply figuring out from the message sent on all the services with one control plane message. You can figure out for all the services what are the membership, when you receive that message from other nodes, for example. Along with that, we are proposing here as well advertising a broadcast node SID. So the broadcast node SID present a node as well and can tell the node that the received packet is a broadcast packet, meaning it's a flooded packet rather than a unicast packet to the node itself. So the broadcast node SID can be thought as well a node SID, but of certain nature, right? Okay. That will tell the node whether it's receiving broadcast packet or not, right? So here we are talking initially. I think the purpose of the initial presentation here is to introduce the concept and explain how segment routing can significantly, improve in control plane for the service, or significantly reduce the number of control plane messages that we have with previous technology, and as well improve as well the data plane via the use of a concept like sRGB or segment routing global block. The next slide here is talking about as well introducing active-active redundancy to the old pseudo-R technologies that didn't allow that. And in here, we are talking about using any SID. I mentioned before that when we build the SID list, we can have, the context of what we call the pseudo-R in the past presented by two SIDs. So as you see here, we have a service SID, and then underneath that, we can have what we call a source SID. So the source SID here could be the node SID if this is a single home, for example, single home host connected to the provider edge, or could be an Anycast SID if this is a multi-home device connected to the provider edge, for which you are providing, of course, the layer 2 service. So if the Anycast SID here is used, then all data plane MAC learning by all nodes is going to be against the Anycast SID. So any return traffic toward that node, the provider edges from which we learned the source MACs, for example, for the multi-home service, can be ECMP or multipassed here to the devices, both devices shown here in the picture, for example, 5 and 6, who are connected to the multi-home service, right? So, so the multipassing and even aliasing can be applied this way. And the idea here is Anycast is already available in segment routing, so we are simply using what's available in the underlay to provide the redundancy and provide the ECMP and the multipassing, right? Layer 2 as well is it's important to do what we call stuff like split horizon. So if a packet is flooded, for example, to the network from a multi-home device, we don't want to create a loop. So we need to make sure that when it arrives to another device connected to the same multi-home site, that packet will not be looping back. And that easily as well can be done because Node 6 co-share or co-own the Anycast SID. So if it's receiving the packet source from an Anycast SID, it will know how to do the proper split horizon here. This is going more into some more details about data plane MAC learning and how can we do that? How can we learn against the source SID for the MAC addresses, source MAC received in data traffic from single home, as shown here from node 3, for example, or even from multi-home, as we're showing in the previous slide. So that's as well is available in the SID list, and we can learn easily for a given service against the source SID, the MAC addresses, for a given service. So going to the next slide. I mean, this is going more into details of how can we do some Arp suppression. And in here, we are talking about flooding Arp replies as well. So all nodes can learn the IP MAC binding. Yeah, actually, maybe a little history about Arp suppression. Arp suppression is calling for, decreasing the flooding of Arp packet across the network. And the way to do that is by doing the Arp suppression, which means that a node can respond to an Arp request, on behalf of the destination. So here the PE router can respond to an Arp request on behalf of the ultimate destination. And the way it does that by gleaning Arp requests and replies to know about the IP MAC binding. And here, of course, Arp requests are always flooded, but Arp replies aren't. And in here, we are saying if you flood the Arp replies, then the gleaning of IP MAC binding can happen. And nodes can learn, of course, about that. Here, again, this is as well a very important point that we will mention here quickly. Is the idea of convergence. And, if, for example, here we have node 5 and node 6 connected to the multi-home device, and if one of the nodes lose connectivity to that multi-home device, what we can do. So as you mentioned, we are using an Anycast SID, and maybe I should stress on that point as well more, per Ethernet segment or per multi-home Ethernet segment. So if one node attached to a multi-home Ethernet segment lose connectivity to that multi-home Ethernet segment, then it can withdraw, okay, any cassette associated with that segment. Doing that withdrawal in the underlay network will simply give us the convergence, right? So we really don't need to do much more, right? I think what's presented here is in the interim before withdrawing, if node 5 would detect that the link, you know, or the interface connected to the multi-home segment is, or multi-home device, of course, right, is down, then it can, in the interim, redirect packet to other nodes connected to that multi-home device until the network converge and things go in track back again, right? Again, we already talked about that, the ECMP multipassing, right? And
Sami,
how it can be, yes, but I'm concluding. Finally, the two takeaways that we want to take from this is the Ethernet layer 2 service we are talking about, presenting it by global SID in each domain, and that will decrease massively you know, the number of states we can keep in data plane, and will decrease drastically as well the control plane signaling needed. And the other takeaway, which is as important, is there is no need really for doing any service convergence, right? You know, like typically as the overlay layer, we always talk about convergence overlay, and defining mechanism for convergence overlay. By the use of any cassette, the problem become an underlay convergence, and there is no need to do any overlay convergence, right? So that's a key takeaway. Finally, the last slide is talking about a benefit in general. You can go over it. The slides are uploaded, and the draft is available too. And with that, I can conclude.
Okay, I'm going to close the queue at this point, but I do want to let the three people who are there comment and ask questions. And I do recommend you go over to the chat and look at some of the questions that have been posted there and respond there, and keep them in mind for mailing list discussions. Patrice? Patrice Brizet, you're up. Please unmute. I'm not hearing anything. Okay, Patrice will try once again when we get to the end of the queue. Eric?
Yes, thank you, Joel, and thank you, Sami, for the presentation. And just one thing, the draft and your slides, it got a section about IPv4 ARP, and I see nothing about IPv6 NDP. Is it the intent to add IPv6 support later?
Yeah, of course. Good question, Eric. Yeah, definitely. You know, the use of network function and SRv6 is, and I think the purpose, Eric, again, is just to introduce the concept, but of course the mechanics and the more details, even the signaling aspect, will come later.
Okay, thank you, Sami.
Thanks.
Okay, Matthew, Tarek, I said I was closing the queue, so. Matthew, your turn.
Yeah, hi, thank you. So Sami, I just got a quick question about the relationship of this draft to one you had in BESS about a year ago. That was very similar, and so.
That's a good question, Matthew. Sure, yeah, go ahead, please.
Could you just clarify what your intention is with the BESS draft? Because I would have thought that this, given this relates to BGP signaled services, should really live in BESS.
Yeah, definitely. I think the idea here, Matthew, is you know, we thought that the concept is more a segment routing concept. So this is why we thought that the concept will present here in spring, but the signaling aspect and the more details about that will be presented in BESS for sure, right? So we will update the BESS draft to more address the signaling aspect and how we can achieve that. And here we discuss more the architecture and the concept.
Okay, I'd encourage you to clarify that in the two drafts, because they look very similar at the moment.
Definitely a good point. And yeah, we will be updating the best draft to more address signaling and of course the BGP signaling for services. Definitely.
Okay, thanks.
Okay,
Thanks,
the Spring chairs will coordinate with the best chairs to make sure that the right material is discussed in the right working group.
Excellent. Yeah.
Patrice, I'll give you one more shot if you can speak.
Can you hear me? Can you hear me now?
There you are. Yes, please.
Okay, sorry. Hey, Sami. I hope you're doing well.
Hey,
a bit along the same comment than Matthew, because I think I was first in the queue, so I had that comment. But also, is there any difference with the two draft right now? The one presented
no,
a year ago in this?
You are right. You are right, Patrice. As I mentioned to Matthew, you know, there is no difference between the two drafts, but the plan is to change the other draft to more address the signaling aspect.
Okay. All right. Thank you.
Thanks.
Okay. Thank you. Sami, if you will now stop sharing. And as soon as he does so, Jibo, if you would then step forward and start and select your presentation. Zhenbin, are you presenting the intent-based routing material?
Yes. Will I share the screen or you share?
You should use the share preloaded slides button at the top. Your screen is being started. As soon as it shows up, I'll let you know and mute myself.
What?
Okay, you're up.
Okay.
Again, yes. Getting your permission again. We'll wait. Matthew, you seem to be unmuted. Please mute yourself. Thank you.
Hello, Joey. Can you help me share my slides?
Okay, I will do it. So let me.
Okay,
This is the intent-based. Let me make sure I find this right one. This one. Share.
Okay. Okay, I can see the screen. Okay,
there it is. You'll have to tell me when to move to the next slide.
Okay. This is Zhenbin from Huawei, intent-based routing. Okay, here's the introduction. In fact, seamless MPLS segment routing describes the requirement for end-to-end intent-based paths spanning multiple domain networks. In order to implement the seamless segment routing, the SR path need to set up according to the pair, color, and endpoint. It means more SR paths need to be introduced in the multiple domain. So this means that not only to set up SR paths for the per endpoint, but also set up the SR paths per pair, color, and endpoint. So this proposes a challenge on the scalability. In order to reduce the scalability challenge, this document proposes the intent-based routing mechanism. Through the mechanism, the intent information can be carried in the data plane, and the network node can steer the packet into the SR policy to satisfy the service requirement. So that means need not to set up the end-to-end path, SR path per pair. So that's not only to the steering the packet into the SR policy according to the intent-based routing. The mechanism can also be used to steering the traffic into the underlying network slicing to meet the specific intent and also enforce the policy for other intent such as network environment and security, etc. Okay, next slide. Okay, so here this is the first page of the introduction about intent-based routing. So first, this is the two concept. That's the color. So that's the color is defined in the segment routing policy. So that's is a 32-bit numeric value that associates the SR policy with an intent. So that means, for example, the intent is a low latency, etc. So means this color can be associated SR policy in the control plane. The intent, so that's mean the new concept. This intent-based routing mechanism introduce the concept of the intent. This means the intent information, which is carried in the data plane to represent the specific service requirement for the destination on the network. So there can be the mapping between the intent and the color in the node. That means the intent X can be mapped to the color Y. So that means if they had similar intent information, so that can be the mapping. Besides this, the mapping, because this the intent can also be used for other purposes, such as the network measurement and the security, etc. Because the color is always associated with the SR policy for the purpose of steering traffic. Okay, next slide. Okay, so here this is the example. So that's the in order to simplify the inter-domain routing. So that's in one local domain. So there's can be set up a SR policy group, which is shown in the figure. So that's the SR policy group. A group includes the mapping between colors and the SR policies for a specific endpoint. So here we can see that this is the mapping between the color 1 and the SR policy 1 and the color 2 for the SR policy 2 for the specific endpoint. Because this is the SR policy group can be set up, and there's also the mapping between the intent and the color. So when the packet arrived at the edge of the network domain, so that's the network node can search the FIB, can search this the SR policy using the destination address in the packet. So then find the SR policy group, go on to use the intent information in the packet to map to the corresponding color, then corresponding the SR policy. So means that use the destination and the intent information in the packet can search the corresponding SR policy for specific endpoint. So then steering the traffic to the SR policy. Okay, next slide. Okay, so the color mechanism can also used to set up the mapping between the color and the underlay network slice. So that's we use that the color can use for the unified mapping process of traffic steering. That means the color can be used for identify the SR policy, can also use to identify the specific underlay network slice. So when the packet arrive at the network edge node, the network edge node can abstract can derive the intent information from the packet, and according to the mapping between the intent and the color to find this corresponding the color, then corresponding the underlay network slice. So that you steering the packet into the underlay network slice, and in the underlay network slice, and use this the destination address can search the FIB and go on to be forwarded in the underlay network slice. Okay, next slide.
Sorry.
So next slide.
There.
Okay.
There.
Okay. So this is the last page about the intent-based routing. So this is the scalability. We have this the advantage of scalability because this mapping between the intent and the SR policy can be done locally without a need of advertising the label binding for the pair, color, and the point to stitch the SR path spanning multiple domains. And also there's the flexibility because the same intent can be satisfied by the SR policy or the underlying network slice. So the local network domain can choose the different solutions to satisfy the same intent. That means in one for the same intent in one network domain can use the SR policy. Another network domain can use the underlying network slice. So that is for the end-to-end traverse the packet. So that's the can flexibly to choose the different solutions in the different domain. So that is combined together to satisfy the intent. So this is can improve the flexibility of the intent inter-domain routing. But I think this is an advantage because now, according to the seamless SR, it can always use it in order to satisfy the intent. It always use the SR path. It's a little difficult to combine the SR policy and the underlay network slice. Okay, and last one, that's the advantage of extensibility because that's besides steering the packet into the SR policy or the underlying network slice for the SRA guarantee. The network node can also enforce the policy for other possible intents, such as the network management and security and other possible intent. Okay, last slide. Okay. Hello, okay. Oh, sorry, not the last. So here, this is just a simple illustration. So we can see that the VPN seed can be advertised from the P1 to the CSD1. And also the SR policy group can be set up in the AS1, and also the SR policy group can be set up in the AS2. So that's the packet, the inter-domain routing can be illustrated. So that's the when the payload to arrived, so that the intent can be carried, and also this the VPN seed can be encapsulated. And also, according to the intent information, can map to the corresponding the SR policy in the SR policy group. So that's the segment list for the SR policies candidate path can be encapsulated for the traffic steering. So when arrive at the ASBR1, so that is the packet. So the segment list can be removed, can use the VPN seed to search the FIB and traverse the packet from the ASBR1 to the ASBR3. So here that's go on to according to the intent information in the packet and to map to the corresponding the
we need to pick up
Okay.
the pace here. We're running out of time. We've got two
Okay.
more presentations.
Okay, so that's done. So that's you find the SR policy in the AS2 and the segment list be encapsulated to steering the traffic arrive at the P1. So this is just a illustration. Okay, next slide. Okay, so this is the next step. So this is the first version. So that we would like to solicit comments and refine the draft and welcome the cooperation. Okay.
Okay, Linda, you may ask your question, but other than that, the mic line is closed because we are running very late on time. I'm sorry.
Okay, I just have a clarification question. So is that intent perform the similar function as policy, almost like a QoS kind of function, similar to QoS in a way that you can steer the traffic, give another layer of policy matching criteria?
To some extent is similar, but to be more exact is like the color. That means the intent, such as this low latency or the high bandwidth. not only just the DSCP. This is the code point.
Oh, okay. Okay. So the payload itself indicates this bandwidth requirement or the latency requirement.
Yeah, it's just some this is abstract in intent. That's not a detailed service requirement. Yeah.
Okay. Thank you.
Okay. Thank you both. Zhisang, you're up. If you will request to present, I will give you permission. Oh, it's not working. Okay, I will present this. I make sure I get the right thing. Multicast. Okay. There you are. I'm going to slide 2. You have only a few slides, which is good, but please proceed quickly. Zhisang. You need to unmute. Okay. There, yes, can hear you. Go ahead.
Thank you. Hi, I will introduce our work about source segment for MSR6 briefly. The first page, yeah, thank you. First, I will introduce the concept of source segment. SRv6 seed is defined to be used as destination address in RFC 8402. But in some cases, an SRv6 seed is also allowed to be used in the source address. For example, when the ping request packet is an SRv6 packet and the echo reply will use the SRv6 seed of the request packet as the source address. In this document, we introduce the concept of source address for IPv6 multicast packet. Next page, please. More precisely, the source segment in this document is used for MVPN service in an IPv6 network. Generally, in the multicast service, a packet is replicated along the tree towards a set of leaf nodes. In this case, MVPN routing and the corresponding information could be encapsulated in the source segment, carried in the IPv6 source address. And this source segment for MVPN is distributed by the root node, and the function is excluded by the leaf nodes. Similar as the group of end.dt functions defined in RFC 8986. This document defines a set of behaviors that can be associated with source segment for MVPN, just as listed the table here. Next page. Thank you. Here we list some benefits which can be brought by the source segment, especially for the case of MVPN. First, the source segment is unchanged along the P2MP path compared to the destination address, and it could enhance the networking capability by allowing more functions in the source space. And also the symmetric of source address could reuse the IPv6 address allocation and management method, or it can have a similar one. Next page, please. What is the next? Actually, we think it is a proper time to raise this topic in spring because this question of seed appeared in source address field has already been mentioned during the discussion of SRv6 compression. And we believe this document could give a clear concept and valid use case for source segment. But honestly, for further work, we believe more clarifications will be helpful. Just as mentioned in the request of the AD's email, maybe there will be a new document for this, especially from the view of IPv6. Okay, that's all. Thank you.
On the queue, and then we have to move on to the last presentation. Torless, you'll go up after this finishes. Ron, go ahead.
Yes. What happens when a packet has a SID as its source address, and for some reason it can't be forwarded, and the node that cannot forward it sends an ICMP message to that source address?
I think this case, the source address is still routable, just like as array6 seed in the destination address.
Where does
And
the
if this,
where does the ICMP message go? Where does it terminate?
just to the locator of the source address, the locator part, it is still routable. Just the VPN, MVPN information can be carried in the such as argument part of the seed, just like an SRv6 seed destination address.
So the low order
Okay.
bits are totally ignored at the source.
Ron, that's a detail we need to take to the list. Xiaohui, sorry if I mispronounced it, your question?
A comment. This concept was first brought up in the beer working group when they wanted to do the SRv6 style beer for MVPN. There were a lot of discussions on the mailing list, mainly from me, on the issues with this proposal. I think we should revive that discussion there.
Actually,
Okay.
I think this is not for beer or some specific mechanism. This can be used for any IPv6 based multicast to carry MVPN. And we also discussed this in the section 6 of the document. Maybe you can review it. And thank you for the comments.
Okay, Torless, you're up.
Okay, let me find it. Is it all the way on the bottom? Page routing. Yeah, there we go. Share.
There you
Okay.
are.
So this idea here was introduced in IETF111, originally targeted for industrial networks, and so this came out of the question: what can we do better with variable length addresses? And it only mentions in a side how it would be beneficial in our opinion for current service provider networks. So I wanted to lay this out as something which I think at the core could really help Spring in the long term, because I think we're going to see a lot more customers coming into our service provider type network use cases without 20 years of V6 and MPLS preferences. And when they're looking at what they can be doing with Spring, I think one of the most obvious feedbacks would be, so why is IETF only continuing to enhance two parallel forwarding planes? Both have downsides, the other solves better. And one common forwarding plane with the best of both worlds would be quite logical. It avoids duplication of expertise, development, software, hardware deployment, and the limitations. And I think that's really, one of the core questions Spring should ask itself for the long term. We have unified SR architecture as much as possible, while we do not have a forwarding plane unification, right? And obviously the current working group structure for execution isn't suited to achieve something like that, because we only have working groups that are there to maintain the legacy. And just imagine how quick would have turned out if we would have been put into the TCPM working group, right? So, and that legacy is quite different from the operator requirements, which we do understand: thin waist, low operational churn, complexity limitation, yada, right? So that's basically the motivation. Now, obviously, any of that motivation doesn't help if we don't have ideas on how to do better and how we could unify. So let me quickly explain how I think all the things we are doing, differently in MPLS and SRv6 could be, done more comprehensively in a single flexible addressing approach. And the main point is that the addresses of each node can be variable length, and no address can be a prefix of another, so that you do own all the suffixes. So, for example, routers 1 and 2 here on the picture are the ones most often used as edge routers, so they have shorter addresses. And then the address is constructed as a sequence of one such node prefix, followed by a sequence of commands, 0 or more, each with its optional parameters. And that could be a superset of the existing SR commands. Let's say the most simple one obviously being something like receive, which could be the value 4 for 4-bit command, receive into a VPN, which might have a parameter, OEM punt, and so on. So how then would we do the most important thing, which is the source steering? And here is the example with the loose steering, where we simply have a sequence of the node prefixes, some local commands here for the first node, command 1 with a parameter, then command 2 being the steer parameter. And with respect to how node 1 interprets the address, well, it's basically the rest of the address is just the parameter to the steer command. So it basically takes the parameter, looks at the first part of it, which is the next hop node, and then it passes on the address in a way that that node 2 and any intermediate hops toward it would start interpreting the address at that stage. And so it goes on. And as you can see, we don't mandate additional local commands on the nodes, like we are wasting the space in SRH, but we can very easily have them. So the address encoding, if we simply strip the prefix of the address on each of these steering hops, we'll basically have an MPLS style address handling, right? We're popping things from the beginning of the address. We can equally do the SRH style. That's a decision to make when we ever get to an encoding of this, by simply having a prefix that we change, an offset, address interpretation offset that we progress in the same way as we do that in SRH. Now, the variable length introduces some new challenges to whether we have, inconsistency in routing in the configuration of the nodes, which will impact the decoding, which so far in SRH and MPLS is because it's fixed size not happening. And we can also easily overcome that by introducing, a prefix length argument that makes sure that whoever is, generating an address will have the same interpretation of the first node prefix to analyze as the receiver has. And if not, then that would erase an error and stop the forwarding of the packet. The very same elimination of new challenges with variable length for the variable length addresses can also be done. We have different ways on how we can, manage address space for commands. So far, we've typically done it by fixing them through the standard, which gives the strongest consistency. They could be pre-configured across the network, which is fairly strong consistency, or they could be managed by the IGP. So to make sure that we're not having inconsistencies across them, we should definitely standardize the address space so that it is always clear what address, what length, and whether it is fixed by standard, pre-configured, or dynamically assigned. So I think this is just high level to see how we can eliminate the new consistency challenges through variable length addresses. And that basically gets us to, how could we start looking at a common header? And this is basically a simple idea on how to start with an IPv6 header, strip it down to take out all the things that we may not want if the semantic we're preferring is more towards MPLS. The source address could be completely optional. The destination address is really that instruction that we had. And I can give a long rant about that. We should get rid of a lot of the legacy QS that we have and make it into an options header. But so we basically would arrive at a very compact header that was very flexible. So obviously there's a lot of functionality beyond addressing. So this would just be the start to show that we can have a unified addressing structure, which makes the Spring architecture more flexible and easily extensible with the best of both worlds of MPLS and V6, right? Obviously, we need to discuss what we think about, other differences in the forwarding, like, is MTU discover better done out of band or in band? And then, of course, also backward compatibility, right? And I think the question is really how much backward compatibility do we need? Not that we need it. And in the most easy case, one can see that with this new encoding, you can simply map all the existing MPLS and SRv6 into it. But is that really what we want? And that's basically it, right? So this is kind of hopefully a somewhat inspiring thought about how we can, do a lot more when we come up with a very simple, flexible addressing mechanisms, and hopefully, long-term evolve into something where Spring has a single unified forwarding plane. Cute, small dogs. Yeah, that's it. Thank you very much for your time, and please take it to the list. Contact me directly if you're interested in this. Obviously, this is not something that can be done overnight, but I'd really appreciate any feedback.
Okay, let me observe. The chairs have not discussed this, but it is very questionable whether discussing this fits at all within the Charter of Spring.
Of course.
I'm not asking whether the IETF should discuss it, but it is very unclear whether it fits within Spring. And we are now at the top of the hour, so I want to thank everybody, and we will see you down the road. Stay well.